right, so here we have 8e to the x, variable in the numerator, over another variable in the denominator. It's important to note, usually we try to split up the fraction into several little fractions and everything, but here we cannot do that because there are two terms separated by that plus sign in the denominator. So the only thing to do is to go through the quotient rule. All right, so I wrote up here the top function, the bottom function. Notice when I take the derivative of the top, 8 is a coefficient, so it will just tag along. The e to the x becomes e to the x by our derivative rule. And then over here, when I take the derivative of the bottom, I'll just have 2e to the x because the plus 1 will go to 0. So plugging into our quotient rule, we are going to start with our bottom times the derivative of the top. So we'll have y prime equals. Now, you'll notice that the bottom has two terms due to that plus sign. So we must put a parenthesis around the whole bottom term or expression so that we are very clear about the fact that we're taking this whole bottom function, multiplying it by the whole derivative of the top. Okay? Then we say minus the other diagonal. So we'll have 8e to the x times 2e to the x. And to be clear, we can just put little parentheses here to really emphasize. All right, and that's all over the bottom, which is 2e to the x plus 1 quantity squared. All right, now there are two options for you here. The first thing is you could look at both of these terms and you could say, okay, both of them have this common 8e to the x, 8e to the x. And so you could factor that out as a GCF. And in a previous video, I talked about how we would factor out the GCF. So what I want to do here, instead of factoring out the GCF, I want to show you how you would simplify this if you decided not to factor out a GCF. So you have kind of a decision about if you want to distribute or factor out the GCF. And our GCF in this case is 8e to the x. But I want to show us how we would distribute this. So what I would do, because this plus sign, I would have to distribute the 8e to the x to each term. So I would distribute here, and I would also distribute to the plus 1. So that would become 2 times the 8, giving us 16 e to the x times another e to the x, plus 1 times the 8e to the x. All right, then we have minus. Now, here you'll notice you have one term, one factor, times another factor. So when we multiply this, we're just going to multiply it all together. We're not going to start distributing or anything. So we just multiply the 8 times the 2 to get 16 e to the x, e to the x. And that is all over 2 e to the x plus 1 quantity squared. Now, by distributing, what you notice is that the 16 e to the x cancels out. And just for completion here, this is also the same thing, of course, as e to the 2x. So you could have also written it that way. And so that will give us 8 e to the x all over 2 e to the x plus 1 quantity squared as our simplified derivative. Now, just as a side note, if at this point right up here, you had said, I'm not going to distribute, I'm going to factor out the GCF. What would happen in that case is we would not have this line here or that line there. We would just be starting at this point. And if I factor out the GCF, I would have 8e to the x. And then left over from this first term, I would have 2e to the x plus 1. And then from the last term, when I factor out this 8e to the x, I will just have minus 2e to the x. And I just want to be very clear, you'll notice that when you do that, e to the x plus 1, you'll notice that when you factor out the GCF, the result is the same as distributing. Because these two e to the x's, they cancel out with the plus and the negative, and then you just have times 1, and then this 8e to the x. So that, of course, will become 8e to the x over 2e to the x plus 1 quantity squared. So either way is fine, GCF or distributing, but you've got to get some way to remove all of these parentheses that happen when you initially start with the quotient rule.